Good morning, folks. Welcome to the new episode of our Alps webinar series. I'm Dominik Wotruba, Head of Solution Architecture Alps Red Hat. I'm excited to have Kapil Arora, DevOps and Cloud Infrastructure Automation Engineer at HashiCorp, Michael Hofer, Head of Engineering at Adfinis, and Kevin Lapagna, Solution Architect Red Hat on the virtual stage. We will discuss secrets management on OpenShift with HashiCorp Vault. I'm thrilled to have as well Csaba Fér, a visual artist celebrity from Austria here on the stage, who will guide you through the presentation by capturing the best moments visually. During the webinar, you will enjoy fun polls and you can ask all questions by the Q&A feature. Stay tuned and most important, have a lot of fun. Kevin, the virtual stage is yours.
Thanks, Dominic, for the introduction. So our talk this morning will be secrets management in OpenShift with HashiCorp Vault. The agenda will look like follows. So first, we'll start with an introduction into OpenShift and its security features and secrets, which will be me. Then we will have an introduction into HashiCorp Vault from Kapil. And in the end, we will go into Vault in production and its specific things that you have to look into there with Michael Hofer from Adfinis. So OpenShift and its secrets. I think OpenShift itself needs no big introduction. OpenShift, as you all know, is a Kubernetes platform. So you have Kubernetes, certified Kubernetes, you have all the tools that you need on top of it. The cluster services, the platform services, the application services, and the developer services for all the applications that you can run on OpenShift in a platform that is really enterprise grade. And on top of it, you have a multi-cluster management that helps you to keep control over all the clusters that you have in your environment. What you have to take care once you have to set up a cluster like this is about the security of the cluster itself. So the first thing you want to do is to take control of the security of your cluster. That means you have to know what applications are running on your cluster and who is running them. That goes through the container content, through the CI/CD pipelines and the deployment policies in your cluster. The next thing, and this is something we take care for you, is once all of this is running, you have to defend it. So you have to make sure that the policies you have to have in place, they really work. And even if an attacker tries to go into your environment, they will fail so, because the security measures that you have in place will work. And the next thing that you have to take care is that you can extend it, because usually OpenShift doesn't stand for itself. It's embedded in a whole environment, and you have to make sure it works with all the other security measures that you have in place in your company as well. What you have to do there is first you have configuration and lifecycle management of all of your containers. You have to make sure that the hosts itself are secure and the runtime, the applications are in there. That means you have to take care of identity and access management, data encryption at rest, and for data in transit, you have to make sure that everything that happens in there is logged and monitored, and that will save the metrics. And you have to make sure that your cluster can be audited and is compliant all the time with the policies that you have in place. This starts with a very basic level if you run a cluster, and this is the Linux that runs below everything. And Red Hat makes sure that this Linux is secure as possible as you can have it for a container system. So everything that we have inside of RHEL 8 is also underneath of OpenShift, which makes sure that with technologies like Linux and the namespaces and the security groups that we have in there, that all the containers are separated from each other and they will never take over space or data from other containers. You also have to make sure that you have fine-grained role-based access control. That means that everything you have set up, all the users that you have in your environment, that they really can only do what they are supposed to do in their environment. And for this, Red Hat helps you with the access control that you have built into OpenShift and the technologies around it, that you can really make sure that everyone can only do in OpenShift what they are supposed to do and see what they are supposed to see. That goes even into the network level, where of course you have a lot of network security already built in Kubernetes, extended with what comes with OpenShift, up to the level that you have a service mesh inside of OpenShift, where you can really make sure that for every application that they only can talk with applications that they're supposed to, and you can track and monitor that with technologies like Keali and Jaeger. And everything is managed with a technology called Istio. Coming to the secrets part of this talk. So first we have to talk about what are secrets anyway. And if you ever managed an OpenShift cluster, you know that we have a split there between the application itself and the configuration of the application. This makes sense because that means you can write the application once, and just by changing the configuration of the application, you can deploy it to several different clusters and several different configurations. And you don't have to make any changes in the container images itself. You can just change the configuration and it runs wherever you want. One special type of configuration are secrets, because the thing is that you want the developers usually that they can configure the application, but they shouldn't have access to the secrets of the application. That means, for example, how you log into a specific database with what username and what password, so that the developer can put in together everything that is needed to configure the application, and an operator who has the rights to see the secrets, or an application, a management application that has the rights to see the secrets, can inject these secrets into the container. So no human will ever see the secrets in this case. And so they're a special type of configuration, and they're handled also specially in OpenShift. So you can put in there your password, credentials, your SSH keys and certificates, and OpenShift will make sure that these secrets are encrypted in transit, and they're also encrypted at the file system level all the time, and they're ephemeral. So that means as soon as a container stops, the secrets is gone as well. This is usually a pretty secure way to handle secrets for a specific node and for a specific node in the cluster. But if you want to handle secrets at scale, to have this secret just in the etcd cluster can become cumbersome. So in special circumstances, it makes sense to go over what OpenShift inside itself already delivers. And here comes into play HashiCorp Vault.
Thanks, Kevin. My name is Kapil Arora. I'm a solution engineer at HashiCorp, and I've divided this presentation about introducing HashiCorp Vault into 3 parts. So we'll talk about the challenges that we see in secret management space. We'll just talk about what Vault is in a nutshell, look at some high-level architecture, how Vault is built, what is the workflow like, and then I will tell you a little bit about how the integration with OpenShift looks like. All right, so first let's talk about the challenges, right? So what are secrets, first of all, right? There are lots of different kinds of secrets. You have certificates, you have database credentials, you have API keys, and many, many more, right? So first challenge that we see with secrets is secret sprawl. What does that mean? That means that human beings are not very good at managing secrets themselves. They tend to write them on post-it notes. Developers tend to write them in configuration files, then check them into the source code. Or also we see people sharing credentials over email or over Slack channels, for example. Many times we have different policies to rotate the secrets to avoid the leakage of secrets, or even if they get leaked, they are rotated frequently, and you have to maintain and manage the system or the automation around rotation of your secrets. And then you have to issue new certificates to your applications, also provide cloud access to your applications. As Kevin mentioned, you also need to probably think about encrypting all your secrets at rest and also during their transit, right? And then you don't only have secrets in an OpenShift or Kubernetes environment. You have secrets all around the place. If you're running an application in a VM, it needs secret. If you're a multi-cloud adopter, you have OpenShift running in multiple clouds, or you have applications running in different clouds. You need to figure out, how do I work with, say, different authentication mechanisms, or actually store secrets in different clouds, or provide secrets to different applications in different cloud, or the same application in different clouds. So there are lots and lots of different things that you need to consider, especially if you are a multi-cloud company. And then if you have secrets, your applications are accessing secrets, you want some kind of control. You want to know who's accessing which secrets. You want to have some kind of management around it. And then you want to audit everything. You need to have a trace as to who accessed what, and have some kind of an alerting system around it as well. And then many companies also need to have some compliance reasons to have, say, for example, an HSM, a hardware security module, or FIPS compliance to encrypt their secrets or any kind of data that they have. And then if you think about in the terms of a CTO or a CE or CISO, you also need to think about, how can we scale secret management? How can we protect secrets centrally? How can we save costs, reduce risks, and also make our workforce more productive? And those are the things that we think about. And then we come to the solution of HashiCorp Vault to try to solve all these challenges for organizations. So let's see what HashiCorp Vault is and what it tries to solve. Of course, the main agenda is secret management, but we also have other use cases like data encryption. So you can offer cryptography as a function, encryption as service, and also you have the capability to do advanced data protection, in which we have things like integration with KMIP, key management interoperability protocol, and also, say, for transparent data encryption, HSM integration, and things like that. Vault is a very, very popular open source tool. We have millions of downloads monthly, and we also have great adoption in the enterprise space, especially in financial institutions. So it's both very, very popular in open source and enterprise space. And lastly, Vault is a highly scalable solution. We have customers adopting Vault and doing trillions of transactions through Vault. So one of the main things that we offer through Vault is a standard or a consistent workflow around secret access or secret management. And now I will take you through this workflow and how it works and how it solves a major of our challenges. So if we look at this picture, we have kind of three participants. So the first participant, we call it as a client. A client could be anything like a person or a container, or in our case, if we are thinking about OpenShift, it could be a pod. A pod needs access to a secret, or we can also say a pod needs access to a system, right? Like a database, or SSH credentials to another system or a VM, or just a key value static credential. So it could be a lot of different things, which we call as secrets. They could be static and dynamic. I will come to dynamic in a bit. And then when this client wants to access secret, it must identify itself first. And for that, we have different authentication mechanisms within Vault. And for the special case of OpenShift, in this case, we will use, for example, Kubernetes authentication method, which is the service account that probably you all know about already. So if a pod comes in and says, I have this service account, it can authenticate itself, but does this pod have access to a secret? So for that, we need authorization, and for that, we have policies. And once there is a policy for this particular client to access the secret, then the secret can be retrieved using a token, for example. And this workflow works for not just for OpenShift, but all kinds of authentication methods and all kinds of secrets with the policies. So we have created the standard workflow and a plugin system of different kinds of secrets and different kinds of auth methods, for example. And this fits into the OpenShift story really, really well. And you can expand your OpenShift environment with different cloud environments or on-premise authentication methods, for example. So that's the standard workflow. Now, if we think about what is Vault made of, what all does Vault have? First of all, I would like to state that everything inside Vault is encrypted, all the storage, and all the secrets are encrypted during transit as well. What it means is it's a security system, and we have paid special attention to make it totally secure for enterprise usage, right? Everything is available as an API, right? HTTP API, and also offers a web GUI and CLI. We have different kinds of identity brokerage, so it can broker different identities. On the left-hand side, you see more person-oriented identities. On the right-hand side, you see more machine or application-oriented identities. Then, does this identity or this person or this machine have access to a secret? So you can write policies, which are all as code as well. And you can also define conditional policies, like only if the request comes from this IP address, this secret can be provided to the application. Then, of course, because the system is a security system, we want to make sure every access to every secret is logged and can be analyzed. So everything is auditable. We have lots of different plugins for auditability. And also we have a Splunk application, right? So you can analyze all your access to the secrets. And lastly, we come to the secrets, right? So secrets could be key values pairs, which are just static, or they could be dynamic, which is the really, really cool part of Vault, because it helps us avoid this rotation of passwords and really attacks the secret sprawl problem. What this means is that I can provide to my applications or my users really short-lived secrets, which are only existing for that short period of time. This means that as a database administrator, for example, I could get access to a database, admin credentials only for 30 minutes. Or maybe as a developer, I could get read-only credentials, which are available for, say, a week or a month, but they don't have the capability to, say, change my database, right? So I can define different roles and then give them access to different credentials, but only get credentials for a certain amount of time. If they need new credentials, they can ask again, right? And for that, we have different plugins to provide that. And lastly, we have cryptography functions like encrypt, decrypt, sign or verify binaries, and stuff like that. So this is what, in a nutshell, Vault offers and is capable of, right? There's a lot more, but to get a small initial understanding, I hope this is very helpful. Lastly, I would talk about what kind of integration do we have with Red Hat OpenShift, and how do we enable people who use OpenShift to do really good secret management. So first of all, we have the capability to actually install Vault itself within an OpenShift environment. For that, we have created a help chart. And of course, you don't have to install Vault within OpenShift, but we have the capability to do that now. Then all the images that we have published for Vault, they're all now part of the Red Hat registry and are certified, which is a very, very important part to support OpenShift environments. And we are working together with Red Hat to achieve that. And then we, of course, support the Kubernetes authentication mechanism and use the service accounts. And just as a side note, we also have really good integration into applications which are, say, Java Spring Boot or other applications. And we provide SDKs so that applications can directly talk to Vault. Another cool integration that we have with Kubernetes or OpenShift is this implementation of the mutating admission webhook. It means that for applications which cannot talk to Vault directly, it is possible to write an annotation within the pod definition, which will inject a sidecar container, which will mount the secrets within the file system of your pod. It means that application doesn't know anything about Vault, but is able to access the secrets using the file system or using a template configuration file. And you can enable different applications with secrets using that. And lastly, we are also working on the CSI driver, which is right now in testing phase. And we have, I think, 2 CSI drivers, different kinds, and that is also available for users who want to use CSI as the mechanism. I also want to mention that we are working together with Red Hat to produce a reference architecture for OpenShift with Vault, which will be coming out in the next months. Now I will hand it over to Shaba to show us what he has been drawing so far for us, and let's have a look at it.
Yes, thank you. Can you hear me, Kapil?
Yes.
Fantastic, cool. So let me just share my screen, which takes approximately 5 seconds from the moment I push the button here. So 3, 2, 1, and it should be there in a second. Just tell me if you can see it. I'm moving around.
Yes.
Okay, cool. So our great presenters today. I think the screen just frozen. Did it? No, it's okay. Now I just have a control screen. So our 3 presenters of today, Kevin and Kapil, already done with their part. And just a very quick overview what I've captured so far. So there was an introduction on the OpenShift platform and its main feature, just to introduce the importance of securing it, as we see this guy over here. And a bit more of it and the components like Linux security, role-based access control, service mesh. So a couple of things I captured here. And then we moved over to you, Kapil, with the HashiCorp Vault, first with the challenges. And in fact, what I understood, there are too many challenges. So of course, there is a human side and then the governance side of keeping up with the challenges, with the secrets and the challenges of secrets in a corporation. And then your overview about the HashiCorp Vault. So it's basically the secure access of secrets, managing any or a lot of secrets, and it's really well established in the market already. And finally, I think the major point, apart from the details you explained, that Vault and OpenShift are really good integrated, and I was just about to make some colors here. So I keep doing it and giving back to Michael, I think, for the next part.
Thank you very much, guys. This looks really awesome. I think I will need a hard copy of these drawings. So for the last part, let's see how these two, so OpenShift and HashiCorp Vault, come together in production. So we'll take a quick look at how to deploy Vault on OpenShift, but also how to integrate OpenShift, so its applications, into Vault, and what should be considered in production to get it up and running successfully. To get a better understanding how the deployment of Vault on OpenShift looks like, it's good to know some of the architecture basics of Vault. So by default, if you just start Vault, which is a single Go binary, it will run a single Vault server. That is good for experimentations, to get more familiar with Vault and its core functionalities. But if you move to production, the standard deployment is a Vault cluster in order to ensure high availability. In a Vault cluster, you typically have 3 or 5 Vault servers, whereas only one Vault server is active at the moment. And that active node will take care of processing all the requests and workflows that come in. All the other Vault servers in that cluster are in the so-called standby node. So they will take care of replicating the configurations, the secrets, the storage, and all the changes. In case of an issue, they have a so-called leader election through the Raft consents algorithm to make sure another Vault server takes over and becomes the new active node. If you deploy Vault on top of OpenShift, you get a few benefits through the container platform. So first of all, if your scalability needs grow, you can also very easily scale the Vault cluster itself. So let's say you increase the amount of OpenShift nodes in your platform, you can also adopt Vault to that to make sure it has an increased availability. So you can very easily scale from 3 to 5 pods through a single adjustment of the Vault deployment in the Helm chart. Another important benefit you get is the scalability, the deployment maintenance part, because you don't need to take care anymore of the underlying operating system. You can really focus on working with Vault and using its core capabilities. At the same time, OpenShift will also take care of the resource management for you, so allocating storage, making sure network traffic comes in, etc. The last benefit, or another important benefit you get, is really the workflows and deployment pipelines. How you deploy all other applications that you have on top of OpenShift also works for Vault, so you can really align all these processes. In a typical production environment, you really want to make sure you are following the reference architecture of Vault and also OpenShift. What that means is that a standard production deployment usually consists of 2 Vault clusters. So one is the Vault primary cluster, which takes care of all the processing, issuing the secrets, rotating them, etc. And on the side, you have a dedicated Vault cluster, which serves as a disaster recovery option. So it will synchronize all the configurations, the tokens, the secrets from the primary cluster. In the case of a failover, you can simply make the DR cluster the primary one, which is quite a simple operation to do. Both of these Vault clusters are also running on dedicated OpenShift clusters. So if there's a problem on the infrastructure layer, you can also easily fail over to the DR option. How this specifically looks like in your environment depends a bit if you are running in the public cloud, for example, or you have a more traditional on-premise data center. But Vault and OpenShift can very flexibly be adjusted to the amount of availability zones in the public cloud, for example, or ES6e nodes in more traditional environments, and also the regions/data centers you have at hand. In many organizations and projects, we often see the very traditional setup of 2 vSphere VMware clusters or data centers, and the setup of Vault and OpenShift can be very well adjusted to that situation as well. There are a few things you should consider and pay special attention to make sure you get a successful Vault deployment. So first of all, really make sure that you reserve time for a proper architecture design. Now this sounds a bit obvious, but from our experience at Adfinis, sometimes see that this is overlooked. And it really also helps you with things like identifying the required personas and roles who want to interact with Vault. And if you identify these early, it will be much easier and better when structuring and creating the necessary policies and secret engines that you need in your environment. Another important point is the auto unsealing of Vault. So whenever you restart Vault, you have to unseal it so it can access the encrypted data. And now, because Vault on OpenShift is running as a pod and could be stopped at any time or scheduled on another node, it's important that that process happens automatically. So you don't need to get up in the night just for a simple unseal process. Another key part is really that you configure Vault not manually, but through infrastructure as code. So here, really make sure that you use great tools like Terraform that allow you to easily manage the whole Vault configuration, all the policies, the secret engines, whatever you need in code, which makes it easy for you to track changes, roll back, but also deploy the same configuration into different environments for testing or integration purpose. Another point I would quickly like to address is the disaster recovery scenario. So really make sure that you have that documented and especially tested before moving to production. Kapil already addressed and gave a few details about the possible integrations of OpenShift and its applications into Vault. And I would quickly like to summarize these options again. So there's option A, which is a native Vault integration into the applications. There are various libraries available for Vault supporting different languages, like Java, for example. So you can really build in the Vault support into your application, which makes the setup also a bit easier. So in that case, your application will take care of communicating to the Vault API, authenticating itself, getting the necessary secrets it needs, and also change them if they are expired. Option B is the admission webhook injection. Now, what this does is that when you are running your application as a container on OpenShift, the admission webhook will inject a so-called Vault agent sidecar container right next to your application container, but it will take care of all the secret management processes for you. So it will take care of requesting the secrets from Vault and storing them in a secrets file that is accessible to the application. At the bottom, you can see such a configuration that is done through the annotations, so that's a sort of metadata of the application deployment. You can see that example that this web application needs access to a database. So the path where the secret is stored in Vault is provided and how the file should look like. And in this case, the Vault agent will put the secrets it gets from Vault, that is a username and password to connect the database, into a file that contains the connection string to the PostgreSQL database. Option C is the so-called secret store CSI driver, which is currently still in a testing experimental phase, as Kapil also mentioned. And this basically allows you to request secrets as native Kubernetes resources. Similar to how your deployment requests storage, network, and other resources, it gets access to secrets. And this allows you to provide secrets not only as files, but also environment variables or Kubernetes secrets. Now, what is important to mind and watch out for when integrating into Vault is to really identify at the beginning how your different applications consume secrets. This already gives you a good understanding what capabilities you need and what kind of secrets you will have in place. So environment variables, files, etc. Also, make sure to verify the behavior of applications when secrets are rotated. Ideally, secrets are often rotated, as Kapil mentioned, also through so-called dynamic secrets. And sometimes more traditional applications don't really like it if the secrets in a file are adjusted or changed on the fly, and they won't notice that. So make sure to test the behavior of your applications. If you have code ownership, strongly consider that you check if you can integrate Vault natively. That will just make the setup more easy, and also your application will support it out of the box. So it will take care of the whole process on its own. Another thing we often see that is important in organizations is to have clear guidelines and workflows how to onboard new applications on OpenShift, but also how to make sure that they get the secrets they need. Make sure that this process is tested and as simple as possible, so it can be done in a self-service manner. With that said, I would like to hand over to Jabra for his awesome drawings.
Thank you, Michael. Can you hear me? Fantastic. So let me start again my screen share. Again, just a couple of seconds, and soon you should be able to see what we have so far. So this is where we left Kapil with the Vault and OpenShift integration. And then here is where you continued with the how-to deploy messages. And you just touched on single Vault server versus Vault clusters and their advantages in terms of high availability, and then the architectures, region A, region B. You just explained a couple of things on that. And then also on the bottom, we see some benefits you touched on in terms of scalability, maintenance, resources, workflows. So therefore the happy face here. And then finally, what to consider part, the second part of your presentation, you started with some considerations how to deploy it, like what I like, the spending time with the architecture, which is obvious and it's not, as you explained. And then a couple of more considerations, amongst them the roles and responsibilities. So who will get access and so on. So therefore our guides here. And then you talk about some integrations like the ABC, three types of integrations with native apps, secret stores, and admission webhook injections. And then the success factors you suggested the people on this call when they're going to going for the solution. So this is what I have so far. So I will make some add some more colors and shadows. But now I'm giving back to Kevin, I think.
Yes, thank you, Csaba, very much for these cool drawings. They're really fantastic. I will share my screen again here to wrap up this webinar. All right, so as you can see, this trio that we presented here really helps you with technology and expertise for secrets management at scale. So that means From Red Hat, you get really a platform, a container platform that basically breathes security through every fiber. We make really sure that the thousands of components have security being thought of by Red Hat. When it comes to secrets management at scale in a huge enterprise, you probably need management that goes beyond what single tools can offer. So HashiCorp Vault integrates everything that is needed for really a big secret management. And the thing is, you need expertise to also bring these worlds together. And for this, you need someone that really knows what they're doing. And there you have Adfinis, the guys that really understand technology, especially open source technologies from Red Hat and from HashiCorp. And they can help you to really get this stuff running in a secure way. Here in this slide deck, you'll find some resources where you can learn about the integration of HashiCorp Vault into Red Hat's OpenShift and how to start with that. And with that, we will go into our next part in the Q&A session where you can ask your questions and we will answer them live here now. Thank you very much. See you right now.
Great. Kevin, Kapil, Michael, Csaba, thank you very much. Really great webinar. Enjoyed it very much. Thank you very much for the presentation. All participants really interested about your comments about the webinar. I ask you a lot of polls, but just feel free to comment it. We will read it, of course. And now let's move to the Q&A. So we actually got a lot of questions. So the first question goes to you, Kevin. You just presented that secrets in OpenShift are actually encrypted. The knowledge, so the guy who asked this question asked that until now, his knowledge was that OpenShift secrets are Kubernetes secrets, which are not encrypted, but just obfuscated. So has Red Hat actually upgraded the Kubernetes secrets to be encrypted and not only obfuscated, Kevin? Kevin, I think you have to unmute yourself. Okay, it looks that Kevin can't unmute himself, so I just read the answer of Kevin. So the secrets can be encrypted as REST now in etcd, and they are, of course, encrypted in transit when sent to the nodes. If you have admin rights in OpenShift, they are just obfuscated. That's right. Good. The next question is about encryption. Are the encryption algorithm already quantum proofed or will be addressed later by Vault? So we get actually a lot of answers on this. So Kapil, maybe you can just summarize what's the correct answer. Or I guess all of them are.
Yeah. To be very honest, I'm not sure what quantum proofed is and how that is done. But we have something called a transit secret engine, which is used for encryption and decryption functions. And we have a bunch of different types of encryption keys that we support. So basically using transit secret engine, you can create the right key for your environment. It could be AES 256, for example, or whatever is your requirement, right? How much time it will take to break some, for example, if you encrypt it with. Then if the key is listed there, then it should be okay to use that key. So that's the only input I could give here. Yeah.
Good, great. So the next question, maybe I just stay with you, Kapil. How to get drivers into the Helm chart? We struggled to get the Oracle driver in.
So as far I know the drivers should already be there. So the database secrets engine is part of the Vault. When you install it, you do not have to separately install it. So I'm not sure why they're not able to see the Oracle secrets engine. Yeah, it should be there ideally in all Vault installations.
Great. Okay. Then the next question, in a secret still encrypted in memory, is the secret still encrypted in memory on the client? When is it decrypted for use?
Yeah, so basically the secret is encrypted when it is in Vault's database or Vault's storage, right? And then when the client asks for it, then over the secure channel, it is also still encrypted. But once it reaches the client and client has it in memory, then it is not encrypted, right? That's how it's how it usually works. So there's no real way, or I do not know of a way that you can have encrypted secrets in memory. All Vault data it's also is not encrypted when it is in memory. So I do not know, maybe there are new technologies with which you can do that, but I'm not aware that we have that in Vault. Michael, if you would like to add to it, if there's something else you want to add there.
No, I mean, once the application basically consumed and requested a secret, and as soon as it's in memory, it's no longer encrypted.
Good.
But the data itself in Vault, as Kapil mentioned, at rest is encrypted. You can also use HSM integration and things like that to further improve the scenario. Yeah, basically it.
Good. Then there is a question about the CSI driver, and I think, Michael, you pointed to the github.com/HashiCorp secret store CSI driver, so it's the right one.
Yeah.
Okay.
There are two drivers, I think, and the one we have pointed to is the one we also have an official guide on, and that is based on the already existing secret store CSI drivers. We actually plug into that, which is already there. I think it's developed in together with Microsoft. I think Microsoft developed that one, and we plug into that. There is one more driver that we are looking into, which is direct CSI driver. So it's not plugging into another CSI secret store, but that is still under development as far as I know.
Great.
Yes, so you will need at least Kubernetes 1.16 to have the feature gate enabled to configure that CSI secret store driver, and it will need a Kubernetes related part, and then on top the Vault driver as well to have this enabled. The link you posted, David, was actually related to the KubeVault operator, which is something else.
Great. So the next question is about auto unseal best practices. So not sure who wants to answer on this. Kapil, maybe?
Maybe Michael can share his experience there. Yeah.
Yeah. So regarding auto unsealing, if you are in the cloud, it's usually the easiest approach because you can use the cloud services like the ones provided by AWS or Azure, etc. And you can simply consume them. There, always make sure that you have the recovery keys at hand, and also you tested the scenarios. For example, if there's an outage or if you want to recover from scratch, etc. And on-premise, usually HSM is the way to go if you have that. And HSMs, to our experience, are behaving very, very differently depending on the vendor and type. There's not a lot of standardization there. So again, check there your architecture of the HSM. If it can be reached via a simple TCP connection, can be easily integrated. Again, check, for example, is your HSM high available? So if there's an outage of the HSM, what is the impact? And again, really check the recovery keys if they work properly, if you have distributed them to the required people. And If you use the transit engine, so another Vault instance, that's also easy to integrate. But again, really check the different workflows and also document them. That's kind of experience from production. I hope that kind of answers the question.
Good, thank you. Then there's a next question from David Ringhofer. He has some concerns from security to run Vault in a container environment. And he asked actually about a white paper or something to just get away with these concerns. So Kapil, maybe you want to answer this?
Yeah, so this is an important concern, right? Because when you're running in a container, say in an OpenShift or Kubernetes environment, you have a shared host, right? You have, and a lot of important data, secret data is in the memory of the container. Somebody does a memory dump, they might be able to get access to very sensitive secret information. So it is a very, very important concern. And therefore, we have created a guide, which I also posted as a link, as a reply, for what are the security best practices for Kubernetes. And we are also working together with Red Hat at this time to release a reference architecture of how to deploy Vault in OpenShift. And then there will be more clarity on the OpenShift side of things. But what is important on the security part, what do you need to worry about? How can you harden it? Is a good guide that I posted already there. So it's security concerns and Kubernetes. We created a Learn guide for that.
Good, thank you. So the next question is there always only one active Vault instance in a cluster? Is there no problems with throughput? Is one really enough for a high number of requests? So I think I will stay with you, Kapil, or Michael, you want to add on this?
Well, by default, most environments can already take care of a huge amount of requests. Also, if you have Vault Enterprise, there's the performance standby node feature that allows the standby nodes that usually just wait there, so to speak, can take care of read-only requests. And also the kind of best practice is if, for example, you're running in different environments or different data centers or different clouds, different regions, can also make use of the so-called performance replica clusters. And they are basically their own independent clusters, but synchronize the configuration from the primary cluster. So they can take basically care of all requests in a certain region. And you can deploy as many of these as you want. They behave all in the same way.
Yeah, to add to that, so I also posted in the chat that we use for consensus and clustering, we use Raft, and it's a open source, so to say, protocol, and it has a different way of handling things, right? And it's built for high availability. People use it in blockchains and things like that, and we use it in most of our tools. And the active node means that that's the one where all the writes operations go through. Right, so that's important to maintain kind of consensus, and there's always a leader. But on a scalability point of view, Vault can be scaled to extreme lengths. We have big customers like Adobe, which have huge SaaS platforms depending on Vault, and we have trillions of transactions going through Vault. So it has already proven its maturity and scalability in that respect. So I would we also have lots of guides. How can you test performance in Vault, and we can go through that as well. I can share those links as well. Yeah.
Great.
Thank you.
So the next question comes from Simon. Is there a best practice for secret management with Vault for scripts that are running on a VM? Kapil.
Yeah. So basically the VM, if something is running on a VM, they need to fetch the secrets from Vault, right? And any application, any script, or any service that needs a secret must authenticate itself, right? Many times you have, say, a script which is already written, which maybe uses secrets from a configuration file, for example. then probably you don't want to change your script and then write code for it to talk to Vault and then use an authentication method. For such use cases, we have something called a Vault agent. This Vault agent is able to run on your host. And say if it is running in AWS, it can assume or it can take the identity of a AWS IAM EC2 instance. And then with the right of that EC2 instance or identity, it can fetch secrets from Vault and use something called a template and populate it in a config file, for example. That way you can bring in such scripts or applications which do not have the ability to change code into Vault. And that's something I also posted that they can look into Vault agent, and that should be able to do their job.
Good, great. So the next question actually comes from Cedric. Can you recommend integration libraries for Java, Go? And actually, I want to add Quarkus as well myself, because Quarkus is a great alternative to Spring Boot, both supported on OpenShift. I really recommend Quarkus. I don't know if you know if there is also integration. So Kapil.
I don't know Quarkus, but we have really good integration with Spring Boot. They developed it, and I think it's very popular in the Spring Boot community. I tried it myself. I just had to change the Spring Boot configuration, and I could just use the library, which is already part of Spring Boot, and just use Vault directly in my code. So that was very seamless, and I was surprised how easy it was for Spring Boot developers. And everything that we do is, I think, mostly in Go. So we have really good Go integration. And I already posted a link to all the SDKs libraries that we have for developers. Vault is a very friendly tool for developers. We have a really cool dev mode. You can just start it on your laptop. And all our tools are very dev friendly. So we really put emphasis on providing SDKs and libraries. So I think we try not to leave anybody out who wants to program against Vault.
Great. So the next question comes from Matthias. If secrets are mounted with admission webhook injection, will a user that establishes a shell into the container be able to read the secrets?
Yes.
Okay, this was an easy one. Okay, the next comes from Eric. Any guidelines on sizing? For example, how much CPU memory is required to do encryption as a service for X requests per second?
Yeah, so Michael also posted the link. I was also about to post the same link. We have lots of good guides for people who want to deploy Vault in production. One is the reference guide, which has this exact information about CPU. We also have a deployment guide and a Vault adoption guide, which is for how do you harden your production instance? What do you need to worry about? So these three documents, if you just search for adoption guide, reference architecture, and you will find the right information if you are an operator and are responsible for it. So really good resources are already available on this, and we have already posted it on the chat. Michael posted, I think.
Okay, and the next comes from Eric again. Here's some question on licenses prices. So he's really concerned that with container and microservices, where you run many Kubernetes services, it might get pricey.
I think we should. So pricing is, of course, a complicated topic. Of course, we do not share exact licensing information publicly. We have sales representatives who directly talk, and I already said we will get in touch with them. And what I want to say is, pricing is a reference thing, right? How much do you have to invest, and how much do you gain from using Vault as an enterprise tool in production, right? If you are losing money by using Vault, then it doesn't make sense. But it should be financially good for you in the sense that you save a lot of manworks, you don't have to implement things yourself, and you get support because it's a critical system, right? If an application is not able to fetch a secret, then nothing will run in your environment. So once Vault becomes a critical part of your environment, it's an important factor that you have good support, you have maybe good features which can provide you disaster recovery, which can provide you high scalability. So it's something that an organization need to consider. But isn't it? is it worth paying for it, right? So that's kind of the main question which comes to it, right?
Good. So the next one comes from Peter. Do you have some simple sample project source code for developing or deploying an application that does dynamic secrets?
Yeah, so I actually, when I was new to HashiCorp, I worked on this small webinar and I built a bunch of Docker scripts, like with shell scripts with 1, 2, 3, 4 steps. So anybody could get it from my GitHub repository. And I also created a YouTube video. It gives you a good sense of how dynamic secrets work and how encryption works in Vault. And you can run through the demo yourself on your laptop in less than 10 minutes. So I posted that link and also the YouTube video if you want like a guided tour. And that way people get an idea. And the code is also there, so you can try it yourself and get. So it's always good to have visualization and some hands-on to really feel, okay, yeah, this is working. And see the passwords getting generated, the application pulling them. So I would highly recommend going through that video or trying it out yourself with the scripts which are numbered 1, 2, 3. So you just have to run the scripts one after the other.
Okay, I just read a comment. So Eric Delemartre used Quarkus actually with Vault. So interesting. Just to mention this, cool. I'm really happy about this. Okay, so but let's go to the next question. Does running Vault in containers not create a chicken and egg situation where secrets are required to run the container, but the secrets cannot be retrieved because it isn't in the vault that is in the container?
Yeah, I think that's a very, very good question. I can imagine I have an OpenShift cluster which completely depends on a bunch of secrets. And my Vault is also running within the same OpenShift cluster, right? So that could actually cause concern. So it might make sense to take that out of the system. And I think Michael does that at many customers. Maybe you would like to share some of the experience, how customers do that.
Yeah, sure. We see kind of both scenarios where organizations still have, let's say, a traditional vSphere, VMware environment, and started to adopt OpenShift or Kubernetes in general. And then if your organization is not like Kubernetes native yet, and everyone is more used to virtual machines and these processes and operational activities, then better start on VMs first until you also get a good experience and feeling of Vault. And then if we also see organizations with basically have the strategy OpenShift first, deploy everything on there. The processes and workflows and pipelines are often already in place, so it's a no-brainer to deploy Vault as well there. But of course, the chicken egg problems definitely are important and should be addressed in your architecture design. So test them, document the process, document how you can recover from scratch.
Great. Wow, this was really a lot of questions. A real big thank you to the absolutely great audience. I think Michael Kapil, we have to do a deep dive on this. I think it's a really interesting topic and I got very good feedback from the audience. I want to here tell you about the next webinar. So it will be in 2 weeks on 5th of March, 8:30, same time. So we run it bi-weekly and it will be about persistent storage for OpenShift across the hybrid multi-cloud. So stay tuned and thank you very much and see you soon. Have a nice day. Bye.